Well, SSL was owned by Loral Space and Communications until November of 2012 when McDonald Detweiler and Associates of Canada purchased us. SSL Federal was then created as a wholly owned subsidiary of SSL to be able to provide secure solutions to government customers. So the marriage between MDA and SSL creates a whole breadth of new opportunities that we can bring to the government customer spectrum. We both have a long history of firm fixed price contracting, a lot of commercial heritage with SSL, coupling that with MDA capabilities in robotics, autonomous systems, geospatial services creates a very unique opportunity for us as a U.S. company, U.S. citizens, to provide those capabilities to our government customers.
Thank you very much. I was kind of wondering, from your perspective, what are the budget challenges for the new national space security policy?
Well, so, the DoD and the U.S. government is going to be a little bit challenged in a different way in the future security environment. In the wars that we've been fighting over the last 10 years, it's been very much a permissive environment to communicate. So what the U.S. government is going to have to wrestle with over the coming decade or so are the needs for protected communications, the need for a lot bigger bandwidth pipes for users that our remotely piloted aircraft, as well as those troops on the ground that just require a lot more data to do their missions, to carry those out. So, we're seeing that they need that protected communications. It's going to be much more dispersed. A lot of the activity has been in one part of the world right now, but we're going to see that that's going to be dispersed also over a bigger part of the world.
Okay, thank you very much. What steps is the U.S. government agencies taking to address this situation?
Well, one thing that the Air Force is doing in an area of protected communications that SSL is involved in is looking at a disaggregated architecture where we're looking at more of the tactical capabilities in a contested environment, looking at a resilient architecture that can create all the mission capabilities that are needed, but not worry about the nuclear environment that some of the strategic command and control for communications are required. That allows us to partner with other experienced commercial customers who are providing capabilities to millions of people around the world today. We're using their services. They're very secure, very reliable. And coupling those things together at a much reduced price point to create opportunities for the Air Force in this case to use for their customers to be able to provide communications to troops in the field, whether those are 10,000s or hundreds of thousands.
Well, in my perspective, the next big thing is something that's been kind of hovering around for a while, but it's really starting to come front and center on the stage, and that's optical communications. There's kind of been a promise of this for a while. Certainly terrestrially, we rely on optical communications through fibers throughout the planet. But that's going to migrate into space as well to get those really big data pipes I was talking about before for those users. It also offers a degree of protection as well with those very tight optical beams. So we see that as a major step in the future. There's been a very key event that has facilitated this, and it's ongoing now. It's NASA's LOTI experiment, where they've sent up a probe to the moon, and they were testing out a laser link back to the Earth at a very high data rate. We're under contract to NASA right now to look at their laser communications relay demonstration and hosting that on an SSL-built satellite. That's going to be a big facilitator for the commercial communications world as well as the national security space world towards getting those much bigger pipes with protection as well.
Is there a role, if you will, for hosted payloads in military communications beyond the technology demonstrations?
We think so, and national policy points to that as well, from the 2009 National Space Policy to the recently issued 2013 Space Transportation Policy, talks about ways of leveraging commercial, ways of doing things collaboratively with industry as well as with our allies. Hosted payloads is a way to marry all of those things together. Chuck talked about the laser comm demonstration for communications, but there are other missions that some cases serve even better to be hosted. Electro-optic missile warning, precision navigation and timing, earth sensing, space situational awareness. Those are all missions that can be served from hosted payloads that can disaggregate, create smaller capabilities around the GeoArc that give that resiliency that a lot of commanders are talking about, allows for graceful degradation of the capability that can augment what those large dedicated programs of record are providing. But what a hosted payload really does is it provides a much lower price point to get to space. You're leveraging a launch vehicle, which is the most expensive portion that somebody else is already paying for to get there. You're taking just a small amount of the real estate on that commercial communication satellite to put a small piece there. So you coupling that with the secure data links down through the terrestrial gateways back to wherever you need the data to go, it really provides a tremendous opportunity. I mean, again, these systems are communication satellites, so what you have on the back end of that sensor is a communication satellite. So wherever we can leverage that capability, it creates a lot of opportunity to make sure that those missions are getting there and creates a different price point and the resiliency that they're talking about. And it's very much in line with where the policy is going. So we're out in the forefront of that. We have a long heritage of hosting payloads. SSL typically wins 6 to 8 satellite commercial contracts a year. We launch 6 to 8 a year. So there are plenty of opportunities. We have a long history of putting hosted payloads in space for different foreign countries, governments, as well as commercial operators. And it's something that we're very familiar with. It's not a particularly technical challenge. Oftentimes it's the programmatic. So clearly there's some budget allocation, but there's also the contractual relationship. And the Air Force is taking a big step towards solving that part by a hosted payloads services indefinite delivery, indefinite quantity contract. And they should be awarding that later this year. That'll create seats on the bus, if you will, for future competitions for task orders with these sensors for both LEO hosting as well as GEO hosting. And so that's a big portion of it, coupled again with the data security. And we have some innovative ideas to solve that problem as well.
How do these issues relate to the civil space communications needs?
Sure. So, you know, there's going to be a continuing and even an increasing need for communications for the civil as well as commercial missions, you know, as we come along. The civil space community is continuing to press deeper into our solar system for exploration. We're looking at doing potentially, you know, whether it's an asteroid redirect mission or a satellite servicing mission, you know, within NASA. All of these things need to have that underpinning of a communications infrastructure that facilitates those kinds of things. I mean, if it's whether it's again an asteroid redirect or a satellite servicing, when you get a spacecraft in close proximity with another one, you know, doing that rendezvous proximity operations, you're going to need to have that reliable, secure communications to have the confidence to have two things in space coming that close together. So, you know, communications will continue to be that key underpinning to facilitate everything in space.
How are the commercial space initiatives going to become relevant to the national security?
I think one way of looking at that is what is the attraction to the commercial owner-operators? And we just talked about hosted payloads on a number of these questions. And right now, the market is driving towards receptive approach of these. One, obviously, from a pure business case. These are very expensive satellites to build and launch. So a hosted payload creates a reduction in the capital expense that they would have to put together for that entire mission. And you couple that with the ability that most companies want to have is some type of a relationship with the U.S. government. That provides a data service opportunity as well. So in some cases it helps close a business case. In other words, it allows it to advance a little bit farther. But from the commercial side, there is an attraction there. So I think with the other vehicles we talked about that the Air Force is putting in place, the policy is in place, you know, just some small amount of budget to make sure that payloads are available, because we're talking commercial timelines. We can't wait around. There's another one that they could get on, but we don't want to hold up that business case. It's all about schedule and delivery because it's revenue focused. If we can have payloads that are built, that are available, I think this can be a great opportunity to move things forward. NASA is probably more forward-leaning, as Chuck said, with the LaserCom relay demo and some other areas for sensing and space sensing observatories. They've realized that, and the fiscal realities are kind of pushing them in that direction.